everybody. Thank you. So I'm Arden Meyer. I'm going to be talking to you today about privilege escalation and master keyed mechanical systems. So first off, if this is going to work, there we go. So first off, I am building on some other people's works. I like to make sure that I give credit where it's due. The chief of this comes from a paper that Matt Blaze, he's a professor, wrote. He published this paper almost 16 years ago now. And then also, a lot of the slides, the animations are courtesy of Deviant. Next. Why is this not working? There we go. Who am I? This guy. I'm actually retired United States Air Force, and then I'm currently a student at Iowa State University. First, we have a few rules in lock sport, and I always make sure that I throw these up when I'm teaching anybody about physical locks. First, do not pick locks that you do not own. Second, do not pick locks upon which you rely. Now, for this presentation, I've added a third rule. Just don't do this. Don't go back to your school, your work, your apartment, and do this unless you have written permission. I will not show up at court and testify. I will not bail you out of jail. This will be very expensive if you are caught doing this. But now on to the fun. So we all know what these are. Doorknobs, padlocks, deadbolts. On the inside, the mechanism is all the same. We have our standard pins, and this is what the stacks look like alongside one another. These are normal locks. What I'm talking to you today are going to be about master keyed systems. Now, where do we find master keyed systems? We'll find them in high-rises, complexes. We'll find them more commonly on universities, in dormitories. This is what a master keyed lock would look like. So in addition to the key pin, which is the red pins on the bottom, and the driver pins, the blue pins on top, we also have these master pins in the middle. That's what allows our master keys to function. So what we don't know is if we're a user and we have a lock that looks like this, I gotta remember which way my slides are. We have a lock that looks like this. We don't know whether that 8 is truly an 8 or if it's a 6 and 2, like we see in the middle, in which case another key with the 6 would be able to operate that lock. So we're gonna go through a little story. This is fictional, just an example. I'm getting ahead of myself a little bit. No, this is correct. So we have a little story here. We have Alice. This is Alice's key. We have Bob. Bob works in a different department. So let's say Bob is a biologist. Alice and Andy are both engineers. These are their keys. Then we also have a maintenance guy. Our maintenance person, he works for engineering, so he needs to be able to open anybody's doors in engineering, but he shouldn't be able to access Bob, who works in biology. Now, what are their keys pinned at? These would be an example of their keys. So Alice's key is a 36235. These are the bitting depths read from the shoulder of the key. Andy has a 35233. Bob is a 47334. And our maintenance guy, his key is a 34231. Everybody's got those numbers, right? Okay. This is crowd interaction, audience interaction. So these are what the keys would look like, or the locks, I'm sorry. This is what the locks would look like. So in the upper left-hand corner, we have Alice's lock. As you can see, Alice's lock will accept her pinnings are a 3 key pin and a 3 master pin, followed by a 4 key pin and a 2 master pin, and so on through the rest of her lock. In the upper right-hand corner, we can see the example for Andy's lock. The bottom left, we can see Bob's lock. Now, the janitor doesn't have his own lock. The maintenance guy does not have his own lock because he can operate everybody in engineering. So here's what would happen if Alice tries opening all of these locks with her own key. Up in the upper left-hand corner, that's her own door. It will work there. We know it's what we expect. In the upper right-hand corner, that is Andy's lock. As you can see, the second and fifth pin, those won't work. And then if Alice tries opening Bob's door, the lower left, you can see four of the 5 pins, she won't be able to open up. So this is Alice's key. Here's what happens if Andy tries opening all of the locks. Andy's key does not work on Alice's lock. It does work on his own. It will not work on Bob's lock. And finally, here's Bob's key. If Bob tries to open Alice's lock, it doesn't work. If he tries opening Andy's lock, it doesn't work, but it does work on his own. Now, our favorite person, maintenance. The maintenance guy can open Alice's lock up in the upper left-hand corner. He can open Andy's lock in the upper right-hand corner. But Bob's building is on a different master keyed system. As we can see, hopefully we can see, the first and third pins still bind. So our maintenance guy will not be able to open Bob's door. Bob, again, works in a different building. So let's consider Alice's key. So for a lock that she can access, we know our change key bidding depths at 3, 6, 2, 3, 5. So obviously this is going to work in her lock, and it opens. That's what we expect. But what can we infer? What do we know about the inside of that lock? Well, we know that the shear line between pins at each point inside of that lock line up with the plug so that it'll rotate. Now, that could be a solid set of pins, just like you would have on your home door, but we don't know, and we really want to figure this out. All of those unknowns are hidden inside of that plug. We cannot examine them with our eyes. So, what do? Well, first step, we want to create what we call an exploratory key, our first key. So we're going to take that key, looks like this, and at that first shoulder, the first bidding position, we're going to leave it at a depth of 0. We're not going to cut into it at all. And then the remaining bidding depths we're going to use from our known change key, the key that we were issued by the school to open our door. Now, we're then going to sweep through this range and try every single bidding depth. Okay? Now, one word of caution, we have to be careful of max, the maximum adjacent cut specification. Now, this varies for each keyway system. In the example that we have up here, my example slides are using the KW7. On the KW7, the max is a 4. So if your adjacent pins are more than 4 bit depths apart, the manufacturer does not recommend that because you can end up binding pins and getting a key stuck inside that lock. So in this theoretical example, right now we have a max violation. But we'll file down 1 bit. So position 1 in the KW7 is the first valid position. Now, how do we know what that is? Well, we can take a easy tool like this that shows us our bit depths, or if you don't have this available, you can just read the specifications. They are available. They have to be available from the manufacturer for locksmiths to use, and just use a set of calipers and measure. But a tool like this that little card makes it much easier. So again, we're going to file down 1 bit. So we are now at the first pin. We have it at bit depth 1. Technically, this is still a max violation, but let's try that key anyway. So we put it inside the lock, but the lock does not open. So we pull the key out, we'll file down a little bit more, and we now have our first bidding depth, or our first pin at the second bidding depth. So we notice that the first and the third pins are both at the second bidding depth. However, they look a little bit different. That's because the third pin we cut properly, and we're manually filing our first position. But they're still the same position on the inside of the lock. Now here, we're not violating max anymore because we are at a difference of 4. So let's try that key. Put it in. Darn, the lock still does not open. So we pull out the key. We'll file some more. We'll get down to bidding depth 3. Try it again. And we're open. Yay! But that was kind of expected, right? Does anybody remember why? Our original change key. We've just remade the key that we were issued. So what we've learned here, though, is we know now that the lower portion, the key pin, is solid. So we still don't know anything about these chambers yet, but we do know that the key pin in the first position is solid. Of course, we could still have some mastering up above it, so we want to continue. So we'll take the key, we'll file it down some more. We now have the first pin at a bit depth of 4. We'll try that key. We're going to find out that key doesn't work. We're going to remove that key, file it down some more, try it again. Still doesn't work. Seeing some repetition here, we're going to remove the key, take it down to level 6, try it in the key. Oh, we've just learned something. The key opens at this level. What have we learned? So all drivers have to be at the right depth now. So given this, we know, got to point to the correct side, we know that on the inside of this first pin, we have our key pin, or the first position, our key pin is a 3, and we have a 3 master pin as well. Now, we still don't necessarily know beyond that. So in the KW7, valid positions are 1 through 7, but we're going to assume for now that we only have 1 mastering pin, and we still don't know anything about those other 4 pins. So this is what we know about the key pin. We know that master pin. Again, there's a chance of more shear line, but in reality, I wouldn't try this. But for my demo, we're going to go ahead and we're going to remove it. We're going to file down 1 more, and we'll try that key. But it's not going to work. So we can continue the rest of the bidding range. If there was more on the KW7, again, valid positions are 1 through 7. So quick set depths don't go beyond 7. So now we're going to prepare another key for the second position. So first, we're going to put the first pin at our newly discovered master pin depth. Then our second position, we're going to leave that at a 0 cut. And our third, fourth, and fifth pins, we're going to use our known change key values. So the 0 depth is never used in a real system. Now, if you're encountering this in a competition, say upstairs in the Lockpick Village or the CTF, maybe you want to actually be careful there, because I can manually pin a lock that will work this way, but it's not technically valid. So we don't need to worry about that in a real scenario. So to save time, we're going to just go ahead and go right down to the 1 depth. Again, max is being violated here, but let's try it anyway. No, the lock does not open. We'll remove the key, we'll file down to bit depth number 2. Max is now okay, so let's try this again. Put it in the lock. Lock still does not open. Okay, so we remove that key again. We're gonna file down again. Now we're down at bit depth 3. Try it in the key. Try the key in the lock, but it still does not open. Remove the key. Again. Now we're down to bit depth 4. We're gonna try the key. Huzzah, it opens. What have we learned? Okay. Again, we know that all of the drivers must be at the shear line for the plug. And on the inside, we now know that we have a 4 key pin, and we know we also have a master pin in here. Does anybody know why we already know that we have a master pin? Just shout it. I can kind of see a hand. So we already know our change key, our original change key. So we've learned this earlier. We don't know about the other 3 pins, but we're currently working that second pin. So now we're done here, essentially, on that second pin. So one of the things with your locks, with master keying systems, we never have a 1-bit depth master pin. They're too thin, they get in the way, they tend to bind and fold, and they cause us too much troubles. So knowing that, we're essentially done here. So we know there's a shear line here because of our change key. Now, if we wanted to, we could go ahead and file that just to check it, but we're essentially done on position 2 because we've found the 4. We know there won't be a 5. We know that there's a 6 from our change key, and again, we also know that there won't be a 7. Back to the fact that master pins are never 1-bit depth deep. So again, single depth mastering pins are rare and bad. So if we wanted, we could take our key and file it down to the number 6, as I said, and try it just to make sure that our card is good or we are reading the right specification. It's going to work. We know what that bit depth was. So further exploring here, not really necessary. We can take note of where we were at. Again, a bit depth of 7 would not be recommended because we have a valid bit depth of 6 and we don't want a single bit depth thick pin. So we know that quickset locks don't go past 7. So now we have resolved the first 2 pins. We have 3 chambers left to go. So now we're going to step on and prepare our third exploratory key. What depth do we put here at position number 1? What we found at the master, so 6. Is this a valid key, by the way? No, this would not be a valid key. This would be a max violation. We're going from 6 to 0. So what cut do we do position 2 at? 4. I have one person playing along in the crowd. Okay, so 4 is what we learned. That's the mastering key because it didn't, or the mastering depth that didn't match our change key, but it still worked on the lock. So what do we put at position number 3? Well, we're going to start at 0 for now because we're now moving on to that third pin and we're going to sweep through that. And for the remaining parts of the key, did anybody remember what those bit depths were? From the change key, we have 3 and 5. So let's explore. Or is it? Is it time to explore? What do we know about that change from our change key? Does anybody remember what the change key's third bit depth was? So our change key had a bit depth of 2. So knowing that, what can we infer about bit depths 1 and 3? Remember, we know they're not going to be valid because we're not going to use a 1 bit depth thick master pin. So 0 is not valid. 2 was our change key. 1 and 3 are not going to be there because we don't use 1 bit depth thick master pins. So honestly, 2 we already knew. So honestly, we can just start at position 4, at depth 4. And this is how we can rapidly go through all of the possibilities. So we're going to start at 4 just to be more efficient, okay? So our key number 3, our exploratory key number 3 is prepared. We're going to put it in the lock and try it. But in this scenario, it doesn't work. We remove the key. We file down some more. We give it a try. Huzzah. Our key has now opened the lock. So this is going to tell us an awful lot about this key, or about this lock. So what do we know at this point on this lock? We have some valid positions. This is where we're at right now. Here's what we know the inside of that lock looks like so far on the first 3 positions. So we don't have any news yet on those last 2. We haven't gotten there yet, but otherwise, position 3 seems to be, we've got it resolved. Do we need to check depth number 6? Again, I wouldn't. Now, again, if this were a challenge lock, maybe somebody's being wicked and evil, and they could put a single depth mastering pin in there, but that's very unlikely. Again, in the real world as well, professional locksmiths just will not do this. So what about depth number 7? Do we need to test that? So it's possible to have multiple master keys systems in there, multiple mastering pins within the same chamber. I would personally skip this at this point and just take a note that I stopped and that I did not test it. If I have problems in the future, I can then come back and test at this particular chamber. So let's just move along, and we're going to prepare our 4th exploratory key. So we're going to start out with the mastering pins, the mastering depths that we've already discovered. So we're going to put our first 3 chambers at 6, 4, and 3. We're going to leave that 4th position blank at 0. And the 5th pin, we use our change key our change key position, which is a bit depth of 5. So again, keep in mind, we do have this max violation right now, but here's our range to sweep. And remember, our change key bidding depth was a 3. So to be efficient, we really only need to test positions 1, 5, 6, and 7 at most, because we know that 3 was our change key, and we know that we will not have a 2 or a 4 if this were a professional door. So we can either code cut or file our 4th position to the number 1 bit depth, and we'll give that a try in the lock. Well, that didn't work, so we remove the key. Now, we could file down to depth number 3 from our change key and test it just to make sure that we are reading the right specifications again. And we could give that a try. It's going to work. We know it's going to work. That was our change key's depth. So we'll remove that key. We're going to skip 4 and go straight down to 5, and we're going to give that a try in the lock. Well, darn, that didn't work. So we remove the key. We're going to file it down again at bit depth 6, throw it in the lock, give it a try. No joy. We still haven't found the mastering pin depth. So what's left? Well, we're going to remove it. We're going to try the last possible depth, 7. We throw that in the key. Does it open the lock? Nope. It doesn't open the lock. What the hell? This is a master and key system. We know that. How could that be? Well, not every single pin has to be master pinned in a master key system. So this is what we know so far. Now, sorry, I threw in another slide. So you could question yourself about that, but again, not every slide or not every pin has to be master pinned. So in this case, in this scenario, our fourth pin is a standard pin. It's not master keyed. So this is what we know so far. We have mastering pins in the first, second, and third chamber at depths 6, 4, and 5. And our fourth chamber, we only have the one pin at depth 3. So let's go ahead and prepare that fifth and what should be last exploratory key. So we're going to code cut to what we already know. So we have a 6, a 4, a 5, and a 3. We're going to leave that last position blank so that we can explore through it. Now we could code cut it to a depth of 1, or we could just file it to 1, and we're going to give that a try in our lock. Right off the bat, it opens. That's awesome. Huzzah. Right off the bat, we found a mastering pin. So this is what we know about the lock at this point. We have found the mastering pin. We're probably fully decoded at this point. Now we don't know, we never did check the 7th position on the 3rd pin, and there are some potentially valid positions still left in the 5th pin that we could test, but now we have found mastering pins in 4 of the chambers, and we swept the entire range on the 4th, on the other chamber. So while there could be some additional cuts in here, there could even be more cuts up on top, up on the driver pin. Honestly though, for me, I would take this key and start checking other doors. Now, one of the things, this key isn't what our key is going to look like though, is it? Our key is going to look a little bit more like this. So you might want to be a little more careful, or you might want to be careful as to who sees this key, because that's going to stand out and look a little odd. If security happens to see you with this key. Now, on the topic of hand filing keys, we want to be very careful because we don't want our key to look like this. When you're hand filing, you can canyon, and if you do this and you put this key into a lock, you're not going to get that key back out. That second or the 4th pin is going to drop down into the canyon at the depth of 3, and you're not going to be able to get it back out because you don't have the proper angle, and now you're stuck at somebody else's door with a hand-filed bogus key, and it's time to find your exit plan. So this is what we know on the internals of our original door lock. So we have mastering pins in 4 of our 5 chambers, and we have our values up on the slides. These are their known mastering depths. Now, the hypothetical alternative lock in the same system. We put our key in, and all of the chambers are, there is a shear line at the same as the plug, so that we could operate Andy's door. And now I'm in Andy's lab, or I'm sorry, Alice is in Andy's lab, stealing Andy's research. Huzzah, a winner is you. So, I'm pretty sure nobody thought that I was actually going to get through 226 slides in 30 minutes. I still have 40 seconds left. So thank you very much. If you have any questions, at this stage, find me afterwards, and I'll try to discuss your questions and help you out with them. Thank you.